Welcome back. So today we're going to be going over the next lesson in this honors geometry course, and we're going to be doing 1.5, which has to do with the division of segments and angles. If you haven't already watched 1.4, again, I would recommend that you pause this video and watch that, right? But I don't want to waste any more of your time, so let's just get right into it. So first things first, right? We're going to be talking about midpoints and bisectors. I know we kind of talked about this in a previous lesson, but essentially, right, just for a review, a point, right, or again, it doesn't have to be a point, it can also be like a segment, an array, or line, right, that divides another segment into two congruent segments. It bisects that segment, right? And specifically, if it's the point that's doing the dividing, then that's going to be called the midpoint of the segment. So, if you want like a visual here, right, here we're given XY, right? Segments XY and AC. And we're also told that XY bisects AC at B, right? So essentially this purple segment here, right, XY, is what's bisecting AC. So it's dividing AC into two equal segments. Because AC is a segment being divided, that's why the result is that AB and BC are going to be congruent, right? So these two segments here are going to be equal. A common misconception is that XB and BY are congruent. Um, that's not true, right? Because remember, AC is a segment that's being bisected, not XY. XY is doing the bisecting, right? And just a side note, right? Only segments have midpoints. It doesn't really make any sense to say that a ray or a line has a midpoint, right? A ray and a line um, don't really have a midpoint because remember, right? Both of these geometric figures contain a line that just goes on forever, right, in an infinite direction. And it doesn't really make sense to have a midpoint when there is an infinity involved. All right, moving on from bisectors, right, which divide uh, something into two congruent parts, right? We have trisectors, right, and it's really similar logic. Instead of dividing something into two congruent segments, you're dividing something into three congruent segments, right? So two points that divide a segment into three congruent segments, uh, they trisect the segment, right? So again, really similar to bisect. The tri here just means three, as in there's three congruent segments as a result of being trisected by 2 points. So again, right, the 2 points at which the segment is divided, they are called the trisection points of the segment. So this figure here, right, we have point E and point F as the trisection points of DG, right, and that's the side on the bottom here, right, DG, or the segment on the bottom. So if E and F are the trisection points, that means they are doing the dividing. So they divide DG into three equal segments, right? And these equal segments are DE, EF, and FG. So those are all congruent to each other. So once again, right, only difference between the bisector and a trisector is the number of congruent segments that you have. So when you're bisecting something, you have two, and then when you're trisecting something, you have three. Um, After that, there's angle bisectors, and in the name, of course, we all learned about bisectors. So angle bisectors have to do with how an angle is being divided into two equal angles, right? So usually the thing doing the bisecting is a ray, right? So a ray that divides an angle into two congruent angles bisects the angle, right? And we call the ray itself as the bisector of the angle, right? So as you see in this visual, you have angle ABC, right? The entire angle here, and essentially we're told that ray BD is the bisector of angle ABC, right? So this ray here is bisecting the entire angle, which means it's splitting it into these two equal angles. So that's why angle ABD and DBC are congruent angles. And also, this is really important, right? Remember, if you're ever writing this down for a problem, right, or when you're doing proofs, right, remember it's BD, it's ray BD, that's the bisector, not ray DB, right? So when you're writing down, just make sure you have the correct notation down. And the theorem, right, remember, right, I told you guys to make sure you know your theorems. So there's a new theorem here, which is highlighted in purple, right? If a ray bisects an angle, then it divides it into two congruent angles, right? So again, just make sure you know that for future proofs. That for the angle bisectors, of course, right? We have angle trisectors, similar logic. Instead of one ray dividing an angle, right, you have two rays that divide an angle. And just to see a visual again, right, here you have angle ABE, right? And rays BC and BD are doing the trisecting, right? So as a result, these three angles here uh, that make up the entire angle, right? They're going to be congruent to each other. So again, very similar logic. Instead of one ray, uh, right, it's two rays that are dividing the entire angle into three congruent angles. And once again, this is a theorem kind of notation, right? Um, If two rays trisect an angle, they divide it into three congruent angles. And these theorems are easy to memorize as long as you know what the definitions are. Um, it comes really easy to your head, right? So an important figure I do want to go over is this, right? This usually causes a lot of kind of inaccuracy in a lot of problems, right? So here you're given that points B and C trisect AD, right? So again, we already went over how like A, B, B, C, and C, D are congruent, right? Because uh, B and C are dividing segment AD into three congruent segments. So these three are of course going to be congruent. Now, a common misconception is that um, these three angles here are congruent to each other, right? Some people think that ray EB and EC are trisecting angle AED here, but that's not true. Even though it kind of looks like these are congruent, you can't actually say that. That'd be wrong to say because we don't know anything about the angles, right? We only know that the points themselves are doing the trisecting. And finally, what I'm going to go over is a proof problem that kind of goes back to what we just reviewed, right? The theorems that we reviewed. So, and again, if you haven't watched my previous video on proofs, I highly recommend you do. All right. But I'm going to follow the same 5-step procedure that I mentioned in that video, right? So, whenever you're given a proof problem, right, first things first, you look at your given. So in this question, right, they gave us a statement and a diagram, which is nice. Um, they tell us that ray WS bisects RWP, right? So essentially, and I kind of draw on the diagrams just to help me visualize things more. So here, right, that ray is bisecting um, this entire angle, and we're trying to prove that angle RWS and PWS are congruent. So let's highlight those angles in red. So we're trying to prove that that angle is congruent to PWS, which is this angle. So now that we kind of gotten the sense of what's happening in the problem, right? We've looked at the givens, we've looked at what we're trying to prove, right? The next step is to write those steps down, right? So first write your given, right? So basically I've done is copied over that given statement that they mentioned in the proof, right? And usually there's a fourth step here, or third and fourth step, which um, in this problem we won't. I will actually skip those because this is a simple proof. We can just go right from the first step to the conclusion, right? We don't need any extra steps to take. So we're already given that WS bisects RWP, so we can go right away and say that these two angles are congruent, right? Because of the angle bisectors, right? We just learned about them. So we can say that RWS is congruent to PWS because if a ray bisects an angle, then it divides into two congruent angles. So this is really simple proof, only 2 steps long. And once again, that's essentially how you do the proof problem, right? Uh, Now I'm going to be going over some more algebraic questions, right? Just so you guys have a sense of how to do those, right? Because remember, geometry, sure, proofs are a major part of it, but you also have algebraic problems. So, and again, after I write these problems down, I would highly recommend that you try to attempt them yourself before uh, resuming the video and seeing the solution. But essentially, let's say we're given a segment, right? And the tail is a segment PR, and there's a point Q here. We're given that the length of PR is 15 units long, the length of PQ is x squared plus 3, and then the length of QR here, right? They tell us the length of QR is 4 plus 2x. So first of all, right, they're asking us to find x. So what is x equal to? And second, they're asking us to determine if Q is the midpoint. And of course, they're talking if it's the midpoint of segment PR. So before we get to determining whether Q is the midpoint, right, let's try to find out what x is. We're given that the entire length of the segment is 15, right? And we're given two uh, other values that make up the 15, right? So it's pretty simple, right? All we can do is just set 15 equal to the sum of this side and the sum of this side, right? So we have x squared plus 3, right, as one component, and then you add that to 4 plus 2x. Now when you solve this, you get x squared plus 2x plus 7, right, equals 15, and you subtract the 15 on the right side, right, so this becomes a minus 8, which equals 0. Now, if you want to factor this, right, which two numbers add up to 2 and multiply negative 8, well, those are going to be negative 2 and positive 4. Right, and then of course our solutions are going to be x equals 2 and negative 4 because you said those equal to 0. So our solutions for x here are 2 and negative 4. Now if you plug in negative 4, for example, into this side, right, you get negative 4 squared plus 3, right, and that gives us 16 plus 3, which is 19. Now 19 is already way bigger than the entire length of the segment, right? So what we can actually do is we can cross out negative 4 as an answer, right? So really the only answer for x here is 2. And of course 2 works, right? If you want to check it, you have 2 squared plus 3, which gives us 7. And here you have 4 plus 2 times 2, which gives us 8. So again, cross out that answer, negative 4, because it doesn't work here, right? It doesn't make sense. Now, the next part of this problem asks us to determine if Q is the midpoint of the entire segment. We learned earlier that a midpoint is the uh, point that divides a segment into two congruent segments. Here we found that the left side is 7, the right side is 8, right? Those are not equal to each other. Now, the only way that Q would be a midpoint is if both of these would be equal, right? So these both would be 7.5. But that's not the case in this problem, so Q is not the midpoint. So hopefully that problem made sense, right? If you're trying to find x, just add the two separate values they give you and sum them up to the total length. And to find the midpoint, to determine if both sides or both segments have the same length. But again, that's how you do this problem. Um, if you have any questions, right, for the specific lesson, leave it down in the comments, and I'll see you next time.